Dart skill presents calculating probability. The probability is the chance of something happening. And it's expressed either as a decimal or a fraction or a percentage. What's the chance of the sun rising in the west tomorrow? Well, the sun can never rise in the west, and therefore we say the probability of that happening is 0. And something whose chance is 0 or whose probability is 0 is called an impossible event. It can never happen, it's impossible. And what's the chance of the sun rising in the east tomorrow? Well, the sun always rises in the east, and it's certain to rise in the east tomorrow, and therefore the probability of the sun rising in the east is equal to 1. Such an event is called a certain event, something that's sure to happen. And because everything in life is between impossible and certain, the probability of anything is always greater than or equal to 0 and less than or equal to 1. And that stays the same if you write it in fraction form. In percentage form, we would say the probability of anything is greater than or equal to 0%, less than or equal to 100%. And the probability of something happening, let's call it an event means something happening, is equal to the number of ways in which it can happen divided by the total number of possible outcomes. Let me explain. Let's say you throw a dice and you want to find out the probability that the number that shows up on the top is an even number. So that can be calculated by using this formula, number of ways in which it can happen. Now we could have an even number. On a dice there are 6 numbers, 1 through 6. So it can be even when we have a 2 or a 4 or a 6. That is 3 different ways, divided by the total number of possible outcomes, meaning that it can be any number from 1 through 6. So there are 6 total possible outcomes. Therefore, the probability that the number that shows up is even is 3 over 6 as a fraction, which is equal to 1/2, or 0.5 as a decimal, or as a percentage, it's going to be 50%. And when we find out the probability of something using math or numerical calculations, it's called theoretical probability. So let me write that down. Theoretical probability. That uses this formula. And there's also something called experimental probability. Experimental probability, in which you do an experiment in real life to find out the chance of something happening. For example, you might want to toss a coin 1,000 or 10,000 or a large number of times to find out that the number of times it shows a heads is more or less equal to the number of times it shows a tails, which means each one has a chance of 50% or 1/2. Let's now talk about something called independent events. Independent events. two or more events are called independent of each other when the outcome of one doesn't depend on the outcome of the other one. For example, let me take you back to those two experiments I was talking about. Throwing a dice and tossing a coin. Now imagine you throw a dice and toss a coin at the same time. And the two things are completely independent. Whether you get a heads or a tails on the toss is in no way going to affect the number that you get on the dice. And in the same way, the number that you get on the dice is in no way related to the chance of getting a heads or a tails on the coin. Such events are called independent events. And if you want to find out the probability of two independent events happening, let's say find the probability of getting a tails and at the same time and an even number. Tails on the coin and an even number on the dice. Because the two are not related, we would simply multiply the two probabilities. So we are going to say this is equal to P tails multiplied with P even. The probability of getting a tails is 1/2. So this is 1/2 times the probability of getting an even number is 1/2. So the probability of getting both a tails and an even number at the same time is going to be 1/4. And then there's something called the fundamental counting principle. Fundamental counting principle. And it tells us that if there are a certain number of things of one type, let's say n things of one type, and a certain number of things of another type, let's say m, and you can carry on and on, you could have a third type of thing and have a number for that type. I'll give you an example, don't worry. The number of ways you can pick one from each type is equal to n times m. If you had another third type, then you multiply this with the number of that type you have. Let's say you have 3 hats and 4 shirts and 5 pairs of jeans. And if you're asked to pick 1 hat and 1 shirt and only 1 pair of jeans, so as to make a complete dress, in how many ways or how many different combinations you could have? And the answer is going to be 3 times 4 times 5, which is 60 different combinations. That's what the fundamental counting principle tells us.